Close your eyes. And in your head, picture the internet. Not your favorite app or website, but what you think the internet itself looks like. Got a good picture of it? Okay, now open your eyes. Ta-da! The internet.
So maybe you're thinking, that's not the internet. The internet is like my Wi-Fi router, huge data center somewhere, numbers spinning through a tube. And that's all basically true, but the internet is also this massive physical network that connects us across the planet, a planet whose surface is covered by 71% water. And it turns out a lot of the internet is actually underwater, running through underwater internet cables. Yeah, pretty cool. Hey, I'm Nat.
And I'm Lo. And we go behind the scenes at Google learning about all the stuff we're curious about. As you can see, we're on a boat. Why are we on a boat, you ask? Well, a little backstory.
Over the summer, we met Dan and Lincoln from this YouTube channel, What's Inside. They cut stuff in half, and for a while, they've been trying to get their hands on an underwater internet cable. Well, we thought we might be able to help them out with that. We eventually tracked down Vijay, a fiber optics engineer at Google that helps create these cable networks, and we also got extremely lucky.
Only a few hours away from our office in New York, one of the companies Google and Vijay work with, TE Subcom, was about to start laying down a new cable system called Monet. Even though there's already about 250 active undersea internet cables that connect major cities and large data centers all over the world, every year we share more information than ever before.
So Monet, which will stretch from Florida to Brazil, will add an important new connection between North and South America. And four companies, Antel, Algar, Angola Cables, and Google, partnered to create it. So, of course, we booked it up there and met John and Chris and Jeff, who showed us around for the day, and we finally got to get our hands on some up-close underwater internet cable.
So very close to shore, it looks like this.
All right, pause. Didn't you think these cables were going to be huge, like tree trunk huge? I mean, we did.
But it turns out, like a lot of things, it's what's inside that counts. And what's inside these cables are extremely tiny strands of glass.
Each fiber is approximately the size of a strand of hair. The fiber has to be of exquisitely high quality glass, so no impurities whatsoever.
These immaculate little strands, these are the internet. And Vijay told us the way they work is by transmitting your photos, videos, web pages as pulses of light.
All these modern cables can carry 100 terabits of traffic.
So just to put that in perspective, that's like transmitting this video that you're watching 10 million times.
This is the beginning of where a cable is made. So you can see before you a number of bobbins of fiber.
The fibers are coded in colors and organized in pairs because they're bidirectional. So, for example, a blue might be sending traffic west and a red sending traffic east. And John told us there could be anywhere from a couple pairs to a dozen pairs in one cable. But typically, each company, like Google, will just get a single pair.
So everything after this that you're going to see is really to protect the fibers.
First, there's a small plastic tube that goes over them, and they stuff it with gel to keep the fibers in place. Then, small steel wires are put around that for strength. Copper is then wrapped around all of that to seal everything in. The copper also helps power repeaters, these large bulges in the tube every 50 miles or so, which amplify the light across the thousands and thousands of miles that these cables stretch. After that, everything's covered in a plastic tube, which looks like this.
This is the insulator to protect the copper as voltage is applied to it. So now this cable from here out is basically ready to go in very deep water.
But where the cable needs to be stronger, like closer to shore or in areas where there's a lot of fishing, they'll add 1 or 2 more layers of galvanized steel with this crazy machine. And then for the last step, a spindle of nylon threads covers the cable, and then it's coated in tar.
Once it's assembled in the factory, it starts its life on a reel, it'll go to a pan, goes into a tank building.
Are these all full right now?
Most of them are, not all of them. We need, that one's empty. That one's full.
So when a ship is being loaded, how many pans would it take to fill it up?
I would have to estimate around 100 pans.
Whoa! From the tank building, the cable makes its way onto the ship down the aptly named cable highway. Then it drops down into the ship's hull where it's coiled in gigantic reels. It takes about a month to load up the ship to leave port, with everybody working around the clock in 12-hour shifts.
When the ship finishes loading, then it'll sail down to where it's going to start the project, which is in Boca Raton, Florida. The ship will get as close as it possibly can to the shore. Then they'll float cable right up to the beach.
Usually, the cable is buried near the shore so it doesn't get in the way of surfers and swimmers. And a remote-operated plow is dragged behind the ship to bury the cable.
We want to get that cable embedded in the seabed. If it's a very soft, gooey seabed, we need to bury really deep. If it's something that's fairly hard, just a little bit of bury will get you enough protection.
The path the cable takes is surveyed out ahead of time so it can run along flat stretches of the ocean floor as much as possible, as well as avoid things like coral reefs, shipwrecks, as well as other bigger challenges.
Across the Atlantic, for example, you cross the Mid-Atlantic Ridge. It's an underwater mountain range. So we have to engineer the cable to avoid the steep slopes, and then we have to change the armor to ensure that it doesn't abrade over its life while it's laying over that rough terrain.
So it's like you're actually laying a cable like across a mountain, up a mountain.
Yeah, if you can envision like a blimp flying over the country, then we're laying the cable from the blimp.
To install the Monet cable, there were actually 2 ships. The first ship started in Brazil and installed the cable up and around, while the second ship, the one that we visited, set sail south from Florida. And then it picked up the cable the other ship had laid and fused it together with the one it was installing to form one long cable. And in case you're wondering, picking a cable off the ocean floor and fusing it together with another chunk of cable is exactly what happens if a cable is damaged, say from an anchor or a hungry shark. Just kidding about that shark part. It is true that they do occasionally bite them, but they don't really damage them when they do.
It's pretty crazy to see the months of work that go into laying just one of these cables. And it's thanks to that work that we have this physical connection between continents, which allows us to see videos and news and photos from anywhere in the world almost instantaneously.
And then to realize this is not some new technology. The first transatlantic telegraph cable was actually laid more than 150 years ago, and it looks almost identical to today's cables. The only thing that's really different is the fibers inside.
The whole idea of putting something as fragile as glass into a cable that has to be pulled and put under pressure that will crush a heavy steel cylinder, and then have it transmit the amount of data it can, is really kind of mind-blowing when you think about it.
Hi, I'm Nat.
And I'm Lo, and this is our 20% project where we go around Google learning about all the stuff we're curious about.
A few years ago, we heard about this crazy idea that Google X wanted to use giant balloons to deliver the internet.
Turns out it wasn't such a crazy idea after all, because now it's a real project, and it's called Loon.
We reached out to see if there's any way that we could see what the team is up to these days. And then they basically asked us, hey, would you like to come to our giant hangar and help us pop balloons?
So of course we said yes. That sounds awesome.
So we went over to Moffett Field and got to hang out in a World War II blimp hangar that's 5.5 acres inside.
And we played with balloons with Mahesh and Pam and some of the other people on the Loon team.
Can you describe what Project Loon is and how it got started?
It all started out with Larry and Sergey's vision, where they basically wanted to connect the whole world.
Right now, more than 4 billion people can't access the internet, and a lot of them live in rural and remote areas.
So it's kind of easier and faster to think of a new solution rather than try to build the same kind of ground infrastructure that other places are using.
What if we change the paradigm? People can live anywhere they want, but we take the tower and we actually float it up in the air.
Specifically 12 miles up in the stratosphere, twice as high as planes fly, where there are these layers of wind that the balloons can use to sail around on. Side fact, in 1902, a French meteorologist actually discovered that the stratosphere exists because of balloons.
This is a Loon balloon. It's a pumpkin-shaped, high-altitude super pressure balloon, which means a higher pressure inside than the pressure in the ambient outside.
What's the balloon inside the other balloon?
That's a ballonnet, which just means little balloon in French. So like in scuba diving, you put on weight to go down and then you let the weight off to go up. This is very similar.
The balloons are the size of a tennis court, and each kind of bulgy flower petal thing is a different lobe.
There's 36 of them, and then 36 tendons wrapped around those that help carry load when the balloons are floating in the sky.
One of the first big problems in the early days of Loon was leaks. Whoops.
These balloons are lasting 5 days, maybe 10 days. So what we did is we formed a leak squad. We all came together to say, what are all the sources of leaks? And then proving out by actually doing testing here at Moffett and other ways.
One of these very scientific tests was asking people assembling and walking on top of the balloons to wear a fluffier pair of socks.
After 6 or 7 months of testing and refining everything about their process, how they make the balloons, how they package them, how they unpackage them, how they launch them, they were able to take their balloons from lasting 5 days to...
We are able to successfully get our balloons to last more than 100 days. Our longest lasting balloon was 187 days.
Which basically means it went around the world like 10 times.
It's like a big noodle.
So even though the balloons are lasting longer these days, there's still plenty of things to test.
Right now we're doing a bunch of tests to inflate to different pressures. So every 100 pascals, we're taking measurements on the film for strain and stretch.
And they do this to purposely pop the balloon so that they can learn more about its strengths and weaknesses.
I noticed my hands just barely touching it were like leaving imprints. So was I damaging it?
No. So the film can handle a lot if you use all the surface area evenly. But if you say take a finger, you could easily poke through it. It's extremely stretchy at what we call ambient temperature. All these materials are optimized once it's up at float and cold.
Because in Moffett, they're testing at room temperature. But, you know, in the sky, it can be like negative 80 degrees at night.
There aren't that many places on the ground that we can get something this big, that cold.
A McKinley Climatic Lab, which is part of the Eglin Air Force Base in Florida. It's a giant hangar, about half the size of Moffett Field, that has unique capabilities of taking it down to minus 40, minus 60 degrees centigrade there. So we've inflated 3 balloons, and then we took the chamber down, simulated going into float.
About 800 pascals.
What is the trigger point? Where does it fail?
Oh, if you just know.
And we got burst.
Then we go do forensics afterward. So we'll pull the film down, we look at it with a polarized light filter. You can see things with this filter that your naked eye isn't gonna call out to you. And it really helps to look at what shape is it, what direction is it, does it have any scratches? It's like shining a giant light on it and instantly everything is clear.
For now, Luna's still in its testing phase. A couple years ago, they helped a rural farmer in New Zealand get online. And last year, they brought the internet to a school in a remote area of Brazil. And we just found out that next year, they'll begin testing in Indonesia and maybe a few other places.
Our goal is over the next few years to be able to start providing good commercial service.
Before making this episode, we used to think that Loon was just like a crazy idea. But now we realize if you look into the history of weather balloons and, you know, other scientific balloons, not this guy, you realize that they've done some pretty amazing things and they're not newbies to hanging out in the stratosphere. All Loon did was find another way to use them. One day, a balloon is going to be flying up in the sky, and we're not even going to be able to see it, but someone is going to be sharing a photo with their friend, and it's going to be because of that balloon we can't even see. Just like anything else, what was once crazy becomes normal.
I planlægger en playboy med sin steddatter og myrde sin rige kone, men sådan en gerne.